Here's a problem from 9C, where we're doing perfect square factorizing, but we're doing more difficult problems like that, where you notice that you've got coefficients here and here, right? You've got a coefficient in front. But what's helpful about this is we know it's perfect square, and if we don't know, we can still check that always to see if it is before we proceed. Knowing that it's a trinomial, right? We know we have a trinomial. That means we have an expression with 3 terms, right? We've got an x squared term, an x term, and a purely numerical term here at the end, plus or minus. So knowing that, we're going to quickly assess and say, hey, can I use perfect square with this? So I check if the first term here is a perfect square. Can I square root 25? Yes, I can. Right? Can I square root x squared? Yes, I can. I can square root 25, that's 5, and square root of x squared is x. Then I look at my last term, my number here. Can I square root 4? I surely can. Square root of 4 is 2. All right. I have a middle term, and that middle term has a sign, and the sign on that middle term is negative. So I'm going to bring down the negative and put this into a parenthesis and square it, because that's what perfect squares do. And I'm going to check that the middle term is indeed the result of the perfect square. So the way I do that is I take my first term of 5x, just on the side, I'm going to do my math here, times the second term of negative 2, and then I'm going to double the result of that. So I end up with negative 10x, and I'm going to double that, negative 20x, and I need to say, hey, is this the same as this? And it is. Therefore, this is a perfect square, and that is my confirmation. If you really wanted to check it, what you would do is you would go back, and you could do the long distribution out, the long math of this, and you could multiply it out, combine like terms, and what you should end up with would be what you originally started with here. That would be your check.